In the early 20th century, even the most respected anatomists like Sir Arthur Keith found themselves baffled by the mystery of the Neanderthals. Who were these archaic humans who once roamed Europe and Asia with remarkable resilience, only to vanish from the fossil record? Their story seemed confined to mainland strongholds until a pair of ancient teeth, discovered deep within a remote Maltese cave, disrupted the narrative. Could Neanderthals have reached isolated Mediterranean islands long before modern seafarers? If so, what else have we misunderstood about their intelligence, mobility, and reach? This isn't just a footnote in anthropology. It's a bold challenge to everything we thought we knew about the human story. In the year 1917, amid the global turmoil of World War I, a quieter but equally profound excavation was underway in the southeastern reaches of Malta. Deep within the limestone walls of Gar Dalam, the Cave of Darkness, a Danish paleontologist named Dr. Jeppe Despot led a meticulous exploration. What they found beneath layers of hardened sediment was nothing short of astonishing. 2 fossilized teeth, one belonging to a mature upper molar, and the other, a deciduous molar, both deeply embedded in undisturbed strata. These weren't ordinary dental remains. Their placement in untouched deposits suggested incredible antiquity, far beyond the island's known Neolithic past. And yet, it wasn't just their age that sparked debate, it was their implications. Geographically, Malta lies south of Sicily, but in terms of zoological classification, it is considered part of the African biogeographic zone. This recontextualization gave the discovery seismic weight. If these were indeed Neanderthal teeth, then their presence in Malta would dramatically extend the known range of Neanderthal habitation, pushing their footprint well into the central Mediterranean. Suddenly, Malta was no longer a quiet outpost of human prehistory. It became a potential frontier in the story of Neanderthal dispersal. Sir Arthur Keith, one of Britain's foremost anatomists of the early 20th century, approached the Gar Dalam find with the cautious skepticism of a seasoned scientist, but what he saw in those teeth gave him pause. He noted the exceptional thickness of the enamel denser than what is typically found in modern Homo sapiens. The roots were broad, splayed, and deeply anchored, a structure designed to withstand heavy mastication. But perhaps most telling were the occlusal wear patterns, flat, heavily abraded surfaces that bore an uncanny resemblance to known Neanderthal specimens. Keith compared them specifically to dental remains from Krapina in Croatia and La Chapelle-aux-Saints in France, two classic Neanderthal sites that had already helped define the morphological standards of the species. The Gar Dalam teeth, though few in number, seemed to fall within this distinctive range. To Keith, the similarities were more than superficial. They pointed to a shared evolutionary history. He was not quick to leap to conclusions, but even he admitted that these dental traits could not easily be dismissed. If anything, they added weight to a bold hypothesis that Neanderthals, or at least Neanderthal, like hominin shad, once set foot on Malta's rugged limestone shores. In March of 1924, under the vaulted ceilings of the Royal Anthropological Institute in London, Sir Arthur Keith took the stage before a distinguished audience of scholars, skeptics, and scientific minds of the era. At his side stood George Sinclair, curator of Malta's National Museum, who had helped oversee the cataloging of the Gar Dalam finds. Together, they unveiled the peculiar dental fossils recovered from the red earth of Gar Dalam Cave, a compact, oxidized stratum located 6 to 8 feet beneath the cave's surface. What made this layer particularly intriguing was not just its depth, but what it held in common with another set of remains found nearby: the fossilized bones of the island's extinct pygmy hippopotamus. The state of preservation, The mineralization, the coloration, the density was virtually identical in both the teeth and the hippopotamus fossils, strongly suggesting they had lain undisturbed in the same geological horizon for thousands of years. This co-occurrence didn't just authenticate the age of the teethid, placed them squarely in the Pleistocene epoch, well before Malta's Neolithic settlers. The implication was clear. These were not recent intrusions, nor the byproduct of disturbed soil. They were part of a deeper, older chapter in Malta's prehistory that Keith now invited the world to reconsider. Despite the promising implications of the Gar Dalam teeth, the broader archaeological context was far from clear-cut. Above the red cave earth, within the overlying layers, excavators uncovered a perplexing mix of Neolithic artifacts, fragments of pottery, worked stone, and even human teeth unmistakably belonging to anatomically modern Homo sapiens. This jumbled stratigraphy raised immediate red flags. Had the cave's sediment been disturbed by ancient burials, flooding, or animal activity? Could the teeth have migrated downward from higher, more recent levels, contaminating the Paleolithic layer and thus invalidating any claims of deep antiquity? Compounding the issue, no Mousterian stone tools typically associated with Neanderthal occupations across Europe were found in direct association with the teeth. Their absence left a glaring hole in the evidentiary chain. While crude lithics had been recovered, none met the typological or technological benchmarks of a Neanderthal toolkit. And so, the entire argument rested on just two isolated teeth-tiny relics in a cave full of temporal noise. Yet despite the confusion, those teeth remained anomalous in every meaningful way. They didn't match Neolithic traits. They stood alone as silent but powerful indicators of a much older, more enigmatic presence beneath Malta's soil. Nearly a century after the initial discovery, the debate surrounding the Gar Dalam teeth has gained new momentum. Modern archaeologists and paleoanthropologists, armed with advanced dating techniques and digital mapping tools, have returned to the cave that once stirred such cautious curiosity. The renewed interest is not merely about re-examining the fossil sits, about re-evaluating the entire framework through which we view Malta's prehistoric timeline. Was the island truly as isolated during the Pleistocene as once believed? Or have we underestimated the capacity of archaic humans to reach its shores, whether by land bridges exposed during glacial low sea levels or through primitive seafaring? Researchers are scrutinizing the stratigraphy with fresh eyes, untangling the complex layers of deposition that once confounded earlier excavators. The context of the teeth is being reassessed, not as an anomaly, but as a possible key to understanding broader migration patterns across the central Mediterranean. If Neanderthals did reach Malta, it would imply a level of adaptability and spatial awareness far beyond their traditional portrayal. And so, what was once a minor archaeological footnote is now being reimagined as a potential turning point in the story of early human dispersal. Decades after Sir Arthur Keith's cautious assessment, modern science returned to the Gar Dalam molars with fresh eye sand, far more precise instruments. A specialized team at London's Natural History Museum, using high-resolution microscopy and 3D dental imaging, conducted a thorough morphological analysis of the larger molar. What they found was striking. The enamel surface revealed tightly packed occlusal grooves and cusp patterns that were not only consistent with Neanderthal dentition, but unique to it. These features are so distinct that experts often refer to them as a kind of dental fingerprint, an evolutionary signature not seen in Homo sapiens or earlier hominins like Homo heidelbergensis. The robust structure, heavy wear, and root morphology reinforced what the crown patterns had already suggested. This was no modern human tooth. It bore all the hallmarks of Neanderthal ancestry. Though the sample size was small, the anatomical clarity was undeniable. For many in the field, this single tooth provided more than just a tantalizing clue. It offered direct evidence that Neanderthals, in some capacity, had left their mark on Malta's prehistoric record. The implications, once speculative, now demanded serious consideration. The implications of the Gar Dalam molar extend far beyond mere taxonomy. They force a reconsideration of the entire prehistoric timeline of Malta. Neanderthals, as a species, are believed to have emerged nearly 300,000 years ago and persisted until around 40,000 years ago, overlapping briefly with early Homo sapiens. Malta's known human history, however, begins much later during the Neolithic period, roughly 7,000 years ago, when agricultural settlers brought megalithic temples and pottery to the island. But the morphology of the Gar Dalam molar, its primitive crown structure, deep-rooted base, and Neanderthal-exclusive wear patterns, strongly suggests an age that predates these Neolithic settlers by tens, if not hundreds of thousands of years. If accurate, it opens up an entirely different colonization narrative for Maltaeon, not defined by early farmers and temple builders, but by archaic hominins navigating prehistoric landscapes far earlier than previously imagined. It hints at a forgotten chapter in human dispersal, when Neanderthals may have moved across southern Europe and ventured into places we've long assumed were beyond their reach. And if that movement included Malta, then the island's role in the human story is far more ancient and far more significant than anyone had anticipated. One of the most provocative questions surrounding the Gar Dalam discovery is not who the teeth belonged to, but how they got there. Malta, though modest in size, is an island that today lies over 50 miles from the nearest mainland shore. But during the Pleistocene epoch, the world was a very different place. Massive ice sheets locked up vast volumes of water, causing global sea levels to drop by as much as 120 meters. This dramatic change in paleogeography likely exposed land bridges or significantly shortened maritime distances across the Mediterranean basin. Could Neanderthals, long thought to be primarily land-bound, have traversed these corridors during glacial periods, reaching Malta on foot or by crossing narrow sea straits? And what if they went even further, dabbling in primitive forms of seafaring, as emerging evidence from the Aegean and Gibraltar now suggests? If early Homo sapiens managed short sea crossings tens of thousands of years ago, perhaps their Neanderthal cousins, equally intelligent and adaptive, did the same. The once dismissed idea of Neanderthal mobility is now being reimagined, not as myth, but as a feasible and even likely chapter in the broader story of human migration. In this light, Malta is no longer unreachable. It becomes a plausible waypoint on a forgotten prehistoric route. Advances in dental imaging have allowed scientists to revisit the Gar Dalam molar with far greater precision than was possible in Keith's time. Using micro-CT scans and comparative morphometrics, researchers have identified a suite of archaic dental traits: thick enamel, pterodont roots, and occlusal surfaces marked by deep, linear grooves and simplified cusp patterns. These features are frequently associated with Neanderthal dentition and differ significantly from the more gracile, complex morphology typically seen in Homo sapiens. Still, not all scholars are convinced. Some argue that robust modern humans, particularly early Upper Paleolithic populations, can exhibit similar dental traits, especially under conditions of heavy wear or dietary stress. But this overlap is limited. When viewed holistically, the combination of enamel thickness, root architecture, and crown wear in the Gar Dalam specimen tilts the scale toward a Neanderthal attribution. It's not one trait in isolation. but the full anatomical ensemble that echoes the teeth found at La Ferraci, Crapina, and Cima de los Huesos. For many paleoanthropologists, the dental evidence stands as one of the most compelling indicators that Malta's prehistoric story includes a Neanderthal chapter, however, faintly preserved in fossilized enamel. What truly elevates the Gar Dalam molar from an anatomical curiosity to a potentially groundbreaking discovery is its stratigraphic context. The tooth was unearthed from a deep, compacted layer of red cave earth, rich with fossilized remains of pygmy hippopotamuses, extinct species known to have thrived on Malta during the late Pleistocene. These strata are estimated to be over 30,000 years old, possibly much older depending on local sedimentation rates and faunal turnover. Importantly, this geological horizon lies well beneath the upper levels where Neolithic tools and modern human remains have been found. If the molar truly originates from this hippopotamus-bearing layer and, not from intrusive activity above it, would place the tooth in a prehistoric window that significantly predates any previously documented Paleolithic presence. The island. There are no signs of disturbance, no downward mixing from more recent layers. The fossil's mineralization and preservation are consistent with other faunal remains embedded in the same level. In other words, the stratigraphy supports the possibility that this tooth is not only ancient, but that it belonged to one of the earliest human or pre-human visitors to Malta. And that challenges everything we thought we knew about the timing of human arrival on this isolated Mediterranean outpost. For decades, the crude lithic fragments discovered near the Gar Dalam teeth were dismissed as geofax naturally fractured stones mistaken for human tools. Early 20th century scholars, lacking today's rigorous typological frameworks, classified them as incidental rather than intentional. But a 2016 reassessment by a team of European archaeologists challenged that conclusion. Using comparative analysis with Mousterian assemblages from Sicily and southern Italy regions known for Neanderthal habitation, the researchers identified striking similarities in flake angles, retouch patterns, and raw material choices. The Maltese fragments, though few and worn, bore enough diagnostic traits to suggest they were not random fractures, but deliberately shaped implements. If these tools are indeed of Mousterian origin, they represent the technological signature of Neanderthals marking presence, adaptation, and cognitive planning. The location of the tools within the same deeper strata as the molars and pygmy hippo bones strengthens the case for their authenticity. It raises a provocative question. Did early investigators overlook genuine artifacts because they didn't expect Neanderthals in Malta? Now, with fresh eyes and refined methodologies, what was once dismissed as debris may instead be a faint but vital trace of Paleolithic hands at work on this forgotten island. In recent decades, the image of the Neanderthal has undergone a radical transformation. Far from the lumbering brutes of outdated textbooks, mounting evidence from sites like Gibraltar, the Channel Islands, and southern coastal Europe paints a picture of a highly adaptable hominin known, capable of exploiting a range of environments, including coastal zones. At Gibraltar's Gorham's Cave, Neanderthals harvested shellfish, seabirds, and even marine mammals, showing an understanding of tidal rhythms and foraging techniques. In France and Spain, engraved bones and perforated shells suggest symbolic behavior, possibly early expressions of identity or ritual. And in the Aegean, lithic finds on islands that were never connected to the mainland hint at short-distance seafaring, or at the very least, planned water crossings. Against this backdrop, Malteric and Ice Age fauna, such as pygmy elephants and dwarf hippos, begins to fit comfortably into a broader pattern of Neanderthal ecological range. Its limestone caves, freshwater springs, and abundant hunting opportunities would have offered ample incentive for exploration or seasonal habitation. The Gar Dalam finds, long viewed in isolation, now gain new meaning when placed within this evolving paradigm of Neanderthal intelligence, adaptability, and perhaps quiet audacity to cross open waters. At Prehistoric Shadows, we believe the Gar Dalam findings are not just archaeological footnotes, they are quiet disruptors of long-standing assumptions. For too long, Neanderthals have been portrayed as primitive, land-bound survivors, shackled to cold caves and simple tools. But discoveries like these suggest something far more complex. They hint at a species capable of bold adaptation navigating, changing landscapes, harvesting marine resources, perhaps even crossing open waters with intent and purpose. What once seemed improbable, Neanderthals reaching isolated island snow, feels worthy of serious scientific consideration. If future excavations and advanced dating methods validate the Gar Dalam molars as genuinely Neanderthal, then Malta's role in prehistory must be reimagined not as a mere waypoint for Neolithic farmers, but as a stage in a much older migration drama, one involving tool-bearing hominins who saw beyond the horizon. So if you're drawn to the mysteries buried beneath our feet, the forgotten footsteps, the unsolved riddles, subscribe to Prehistoric Shadows. Because history isn't finished. It's waiting for minds bold enough to keep questioning the stones,